So here's another episode in the limited series of Math People. Please start making sense to people who are trying to program stuff for you. Okay, so what we're going to do here is matrix, and let's see. What are we going to do? Oh, yeah. Okay, so the idea is, say we've got a summation that looks like this. So we're going to actually have a summation that says, okay, J on the set of J and K in the set of K, A sub J sub K, like that. Now, theoretically, I think there's supposed to be like a comma here, but that gets really, really hard to write, so I'm just going to go J, K, and y'all can just be cool with the idea that there's supposed to be a comma there. All right, and somewhere along the way, there would be some kind of a notation that J would be the set 1, 2, and 3, and capital K would be the set 1, 2, and 3. And this would be like the mathy way of saying things like, clearly, everybody knows what this means. And you're like, I guess so. But really, I'm going to go ahead and rewrite this as a programming person might like to actually see. Basically, you can think about this as two separate summations. So we're going to sum J, in our case, is going to be going from 1 to 3. And then K is going to be going from 1 to 3. And we're going to sum A sub JK, like that. Awesome. Okay, so you always want to think of these summations as, not always, but, well, yeah, always. So these summations that are like this, you can think of as like a nested for loop. So it just kind of depends on whether your brain likes to think in summations or if your brain likes to think in for loops. But you can use one to understand the other. And so, so that's kind of what we're trying to do here. So you could say, all right, so for J going from 1, I'll do it like this, from 1 to 3, and then for K, going from 1 to 3, we would say, okay, so whatever sum that we're currently doing, we would take the previous value of the sum plus the new, A sub J K. So that would mean that we would need to start by initializing our x at 0 because we're adding to it, because you want to start at 0 and then add stuff to 0 because 0 is the neutral for addition. All right, so a way to think about this now, what's physically happening in the system, we would say, okay, so the first thing that happens, if I'm looking at this, so I'm looking at this over here. So the first thing that happens, you think, okay, so J is kind of equal to 1, and then K is going to, so once J is equal to 1, I'm going to do a for loop where K is going from 1 to 3 of A1K. And if you think this is stupid, that's okay, just whatever. This is just a way to think about it and to kind of picture it. And it helps whenever we get, in a minute, to a discussion of more the dependent variables. So right now we're looking at J and K being independent. So that would kind of let you have A11 plus A12 plus A13, all right? And then J would go to 2. So really you have, again, the summation of K going from 1 to 3, where I have A2K. So you have plus A21 plus A22 plus A23, all right? And then you're going to set J equal to 3, and then again, K is going to go from 1 to 3 of A sub 3K. So you have plus A31 plus A32 plus A33. All right, so doing that is the same thing as what we see in our for loop, right? We set J is equal to 1, K goes from 1 to 3. J is equal to 2, K goes 1 to 3. J is equal to 3, K goes from 1 to 3. So however this makes sense to you, that's kind of what I'm trying to do here, is just show it to you both ways so your brain can go, oh, okay, I understand. Now, again, because J and K are independent, let me see, are independent, so we can switch them. So Philippi's are okay. So since they're the same, they have nothing to do with each other. I mean, they're both 1 to 3, but they could not be 1 to 3. Like J doesn't care what K's doing and K doesn't care what J's doing. So I could actually flip the order here. So instead of having J going from 1 to 3, I could start with K going from 1 to 3, and then J going from 1 to 3, and then adding A sub J K. And basically what that would do is that would flip your these two lines in your for loop. But essentially what it's going to give you is it kind of looks like a transpose, because now you're going to hold K constant, and then J is going to go from 1 to 3 of A sub J1. So that would be A11 plus a, what's he does it, 2, 1 plus a 3, 1, right? Like that. And then you could say, okay, so now k is going to be set to 2, and j is still going to run from 1 to 3. So I've got a, j, 2. So that adds a 1, 2, a 2, 2, and a 3, 2. And then k goes to 3. And we're still adding j going from 1 to 3. Okay, this will make more sense why we're going through all this whenever we get to the dependent stuff in just a second. So this would be a 1, 3 plus a 2, 3 plus a 3, 3. Okay, now if you go compare these to what we had a second ago, as I keep getting larger and larger font because I keep scrolling out more and more, zooming out and out more and more. Let's fix that. All right, there we go. So essentially what you're getting this way is here you're doing things by the columns, and here you're doing things by the rows, and here you're doing things by the columns. So here is our original. So this right here is row, 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 and that's row, 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 like that. Then the alternative way of looking at it would be to say adding by column, column, column. And that's what we're doing here, column, column, column. And again, I said this in the other video, but whenever you're adding stuff or manipulating matrices in general, different programming languages store things differently. So sometimes it's faster to access stuff via columns, or sometimes it's faster to access stuff via rows. And it just kind of depends on your programming language and how you're storing the variables and how everything's set up. But sometimes you can actually get a significant increase in processing speed by, or not increase in speed, but in processing efficiency by doing things in terms of columns instead of rows, or rows instead of columns. So knowing how to do these things differently and how to think about them differently is really important as a programmer. Okay, so this is fine when they're independent, but let's talk then about what happens when they're independent, or when they're independent, let's talk about what happens when they're dependent. So like, let's say I've got a summation that says j goes from 1 to 3, and of course none of processing times matters when you have a 3 by 3 matrix. We're just doing this because I don't want to have to, the only time it matters is when your processing time is going from like 10 hours to 2 minutes, and that's just not something I feel like displaying right now. All right, so of a sub j, okay, so to make sure you understand what's going on here, my handwriting is so bad when I write little chirps. Okay. So the first thing you always, this is the outer loop, and then this is the inner loop here. So inner, or that's the inner, and then this is like the outer. Another way to think about this is kind of like f of g of x. You know, this is your inner loop, and this is your outer loop, that kind of thing. Okay. So anyway, what are we doing? Oh yeah. So we have a j is going to be started off equal to 1. And whenever j is equal to 1, then remember that k is going specifically from j, which is 1 to 3 of a sub 1k. All right, so what that gives us is a 1, 1, a 1, 2, and a 1, 3, like that. Okay, then the next thing that happens is that j is equal to 2. Now, as I'm doing the summation, remember k is at j. So now, instead of starting k at 1, we're actually starting k at 2. So k is going from 2 to 3. So it's a of 2k. So it's plus a 2, 2 plus a 2, 3. Now, I left this spot open because what should have been a 1, 2 isn't there, because it's not allowed by the summation. And I'm just trying to give you a visualization of that. Okay, and then we have j is equal to 3. So again, k is going to be going from 3 to 3. So that's j to 3 of a sub 3k. And so really the only term that's allowed is a sub 3, 3. So we kind of have this upper triangular thingy going where we're only adding the top right-hand side, or the diagonally thingy of the, what's it called, of the matrix. Now, from a programming perspective, this is going to look basically exactly the same as the other things. We're going to have a for loop where we say, so for, j is going from 1 to 3, and then for, I can't spell for starts with an F, not a K. For k, that's not a K. For k going from j to 3, then I would say have x is equal to the previous x plus a j k. Something like this. And. So something like that. So this is a little bit more friendly, I guess. Now, the thing is, this makes sense. So if someone give this to me as a programmer, I'm like, okay, I get what's going on. Let me show you how they're going to show that to you in math speak. So in math speak, well, okay, let me write it in programming first. So in programming-iness, it's not that this is not, I mean, this is still clearly math, but this is more obvious to me that this is a for loop. So k equals j to 3, and then a, how I should say this. This is less obnoxious. This is a less obnoxious way to say this. Least obnoxious way to say it. I can look at it, find out exactly what I'm doing. But of course, you know, what's the point of being clear if you can be not clear and charge people more money for your talents? Or be so valuable they can never get rid of you because no one can understand what you're doing. All right. So this is the other way to say it. So you can say 1 is less than or equal to j, is less than or equal to k, is less than or equal to 3, and the sum of a, j, k. Okay, so those two mean the same thing. Now this is different. In a previous video, what we had was 1 is less than or equal to j, comma k is less than or equal to 3, because that meant that j goes from 1 to 3 and k went from 1 to 3. So I'm not going to write this too close because I don't want you to think it's the same thing. So these guys, that's what this means. So whenever I say blah, I also mean blah, and that's the same blah. That's not what this is because this is a less than or equal to sign and not a comma. So it's one of those things, if you're not paying attention, you're not necessarily going to see the difference or notice that. So there's two ways to interpret that. So one way to interpret this is to say, okay, so I'm going to focus on the j at first. So I'm going to say, okay, so j has to be less than or equal to, or 3 has to be between 1 and 3. So j has to be between 1 and 3, and k still has to be less than or equal to 3, but it has to be greater than or equal to j. So the first thing I would do is I would control j going from 1 to 3, and then k is going from j to 3. So that's how we have this written out, is this way. Now, another way to interpret it is to start with the k and say, well, actually, it's the, if you really want to be obnoxious about it, it's the k that goes from 1 to 3. And then how I kind of do it is I kind of pretend that that k is not there. Or not that k is not there. Yeah, I kind of put my finger over the k. And then I'll say, now what's left is that how I do it? I think so. No, hold on. That doesn't make any sense. I crossed something out. Oh, I think it's the 3. Oh, that's what I was going to say. So to get this one, that's what I do, is I would kind of cross off that j for a second. That's what I'm trying to say. Cross off that j for a second and then say, oh, so that means that k goes between 1 and 3. And then I take that off and I say, okay, so now what's left? Now I have to look at j, and j is defined as going between 1 and k. Okay, so that looks completely different because now I'm controlling on k. So k is the outer loop, and then the inner loop is going from 1 to k. So I'll show you what that looks like. So we would say the sum as k goes from 1 to 3, and then the sum as j goes from 1 to k of a sub j k, like that. Now it's kind of funny because you get, again, the same kind of answer, but in a different order. So basically how I would interpret this is I'll say, okay, so the first thing is that k is going to be equal to 1. And I'm actually going to do this in columns because it's going to line up a little bit better. And then the summation as j goes from 1 to k, which is 1, of a j 1. So that's basically just a 1, 1. All right. And then I'm going to say, okay, the next thing that happens is k is equal to 2. So j is going to go from 1 to 2 because I'm matching 1 to k. So 1 to k, 1 to k. All right. Of a sub j 2. So I've got a 1, 2 plus a 2, 2. Don't freak out about me doing this in columns. I'm just doing it. Otherwise, it doesn't doesn't look upper triangular anymore, even though it still is. All right, and then the last thing would be k is equal to 3. So j is specifically going from 1 to 3 of a sub j 3. So that's a sub 1, 3 plus a sub 2, 3 plus a sub 3, 3. Again, it's just summing by columns instead of rows, or rows instead of columns. Now something that happens, so notice here that I did switch the order of j and k, but I still had to make an adjustment. So up here, let's see, here I was able to switch j and k. Yeah, I could go on k, or I could go on, oops, not this one, over here. All right, I could go order j 1 to 3, and then k 1 to 3, and then here I did k 1 to 3, and then j 1 to 3, and it was the exact same thing, and I didn't have to worry about it. Over here, I couldn't flip the order without changing a lot, because like if I just kind of tried to troll my way through this, then I'd have something to look like k is going from j to 3, and then j is going from 1 to 3, which if you know anything about programming, the first thing that's going to happen is k is not defined. So you can't just flip the order. You have to flip the order and think about it. And if you said, well, I'll just flip the order and not do anything else. So I'll just say, so k goes 1 to 3, and j goes k to 3. What you're actually going to get is the lower triangular summation of that. So you can't just flip it without knowing what you're doing, which is, I guess, why this stupid thing here is kind of valuable, because it contains that information. But for me, it almost makes more sense just to look at the difference here. Okay, I lost my train of thought. So basically the whole point is that when things are independent, you can flip them around and they're flippy happy, but if things are dependent, you absolutely can't. And even though like mathematically the order doesn't matter in which you're adding things together, like computationally they totally can.